So now we have what's called the conjugate pairs theorem. So what are conjugates? If I have A plus B times A minus B, notice that equals A squared minus B squared. This you should just know always. A plus B has a conjugate that is A minus B. A minus B has a conjugate that is A plus B. So those are called conjugates. If I'm talking about something with a complex value, notice here, if I have some A plus BI, my conjugate is A minus BI. Okay, so that's what conjugates mean. If my value is A minus BI, my conjugate would be A plus BI. And if I multiply those together, I would get A squared minus B squared I squared, right? Because it's the difference of squares. But I squared is -1, so I would get A squared plus B squared. And that's the conjugate pairs theorem, okay? A polynomial f of odd degree with real coefficients has at least one real zero. So if I have anything like with a cubed, I could have complex numbers as my zeros, but I'll always have one real zero. The reason for that is conjugates always come in pairs. So if I have a complex number, I always have to have its complex conjugate, okay? So for example, I want to construct here a polynomial from its zeros. What do I know? I know that it's degree 3. So my largest term has to be x to the 3rd power. And it has zeros of -1 and 2 plus I times the square root of 3. I want to find my polynomial. This says assume A is 1, which is my leading coefficient, okay? So I know I have a 0 at -1, which means I have a factor at x plus 1. I also have another 0 that's complex. So I have 2 minus 2 plus I times the square root of 3, right? Because 2 plus I times the square root of 3 would make that 0. And because complex numbers always come in pairs with the complex conjugate, that also means I have x minus 2 minus I times the square root of 3, because I have to have my conjugate 2 minus I times the square root of 3. Okay, so now I have 3 linear factors. I'm going to say this is equal to P of x, but of course I'm not done yet. I'm not done yet because I don't have a polynomial of the form x cubed plus ... All right, so now I'm going to show you a little trick. I like this trick. I will always use it. Hopefully you'll understand and you'll be able to use it as well. First thing I'm going to do is I'm going to multiply these 2 factors together. And I could, of course, do it the way I showed you before. I have 3 terms. I can use vertical multiplication, but I have kind of a better way. So first thing I'm going to do is I'm going to rewrite them I'm going to distribute the negative sign. So I have this times x minus 2 plus I times the square root of 3. Okay, so all I did is I took those 2 terms, I distributed the negative. Now, because I know that if I have A plus B times A minus B it's always going to equal a squared minus b squared. I'm going to use that fact. And what I'm going to do is I'm going to change the order of the parentheses here. And I'm going to say, let's let x minus 2 be one part minus I times the square root of 3. And then again, I have x minus 2 plus I times the square root of 3. Now, notice if I say here that a equals x minus 2 and b equals I times the square root of 3, I actually have the difference of squares. I can say this right here is equal to x minus 2 squared minus I times the square root of 3 squared, because that's the difference of squared, a squared minus b squared. And now I can simplify this by saying this is equal to x squared. So x minus 2 squared is x squared minus 4x plus 4 minus, and again, this is going to be I times the square root of 3 squared, which is going to be 3I squared. I'm going to keep simplifying that. X squared minus 4x plus 4. I squared is -1. -1 times -3 is plus 3. So x squared minus 4x plus 7. So now, if I'm multiplying x minus 2 plus I times the square root of 3 times x minus 2 minus I times the square root of 3, using that little simplified trick, and you can do it however you like, I get x squared minus 4x plus 7, okay? But of course I'm not done, because I have to multiply x squared minus 4x plus 7 times x plus 1. And again, I'm going to use my vertical multiplication, which gives me, I'm going to multiply the entire top polynomial times x, which gives me x cubed minus 4x squared plus 7x. Then I'm going to multiply the entire top polynomial by 1, put it under where the easiest place to go. So I have x squared minus 4x plus 7. I add down, and I get x cubed minus 3x squared plus 3x plus 7. And that is my polynomial. Now notice I constructed a polynomial of degree 3 with real coefficients, and those are my zeros. So basically, this is the final answer. Okay, hopefully y'all followed that. I'm going to do another one. So here I want to find a 4th degree. So now I need how many linear terms? I need 4. Okay. And it says 3 is the only real 0. So that means I know one of my factors is x minus 3, because that gives me 3 as my real value. I also have a 0 at 2i, so that would be x minus 2i. But because it's complex, I also have to have its complex conjugate, which gives me x plus 2i. And again, I'm still trying to construct my polynomial. But if I multiply these 3 factors together, what am I going to get? Am I going to get a 4th degree polynomial? I am not. I'm going to get a 3rd degree polynomial. So, what am I going to do? Well, remember that complex numbers, complex zeros always come in pairs. So I can't just make one of these squared, because I'd have to make both of them squared. But we don't have a rule like that for zeros. So since 3 is my only real zero, I can just square it, make it a multiplicity of 2. And now when I multiply this together, I'm going to get a 4th degree polynomial. So let's start. X minus 3 squared. So another formula that it's up to you whether or not you learn it, but I think it's important, is if you have a plus or minus b squared, it's always equal to a squared. It takes the sign 2 times ab plus b squared. So those are the two really special ones. We have the difference of squares, and this is called a perfect square trinomial. This is called a perfect square trinomial. And I do think that it's important enough to remember. It's up to you. Okay, so if I use that formula, what I do is I get x squared, and then 2 times a times b. Well, a is x and b is 3. So x times 3 is 3x times 2 is 6x. And because it's negative, it becomes negative 6x. I add them together, plus b squared, which is 9. And then if I multiply these two together, hopefully you notice that that's the difference of squares. So that's going to be x squared minus 2i squared, a squared minus b squared. So let's continue. I get a squared minus 6x plus 9 times x squared minus 2i squared. Well, that's 4i squared. I squared is -1. So it's -4 times a negative makes this +4. Okay, so now I'm pretty close to my polynomial. I'm building my polynomial from its zeros. And then again, I'm going to do my multiplication. X squared minus 6x plus 9, x squared plus 4. I multiply, I get x to the 4th minus 6x cubed plus 9x squared. That's the entire top times x squared. Now I'm going to do the entire top times 4. Notice here I get 4x squared, so I'm going to put it right here under the x squared. 4x squared minus 24x plus 36. I add straight down. I get x to the 4th minus 6x to the 3rd plus 13x squared minus 24x plus 36. And that is my final answer. That is p of x. And notice it is a 4th degree polynomial because I've multiplied 4 different linear factors together. So there we have it. So that's more multiplication, but now we're building it given our zeros, okay?